Alright, should be a video beginning, and good news for a change. We actually got a response from a physicist regarding a portion of the video he did watch anyway, and okay, it's not very responsive, but it's a response, and that's a very positive thing, and maybe whatever it takes, I can get him to continue to respond. If I have to pay him, that's okay. Pay him to stay interested in the subject and resolve, the subject with actual, evidence. I mean, as physics shouldn't mind somebody saying, show me. And so if I say, show me, he should be able to produce some sort of evidence indicating that what he claims to be, my misunderstanding is truly my misunderstanding, and that it's not really there or his misunderstanding. So anyway, I watched through the bulk of your response, and you seem to have some confusion. Now, the argument is that the work equation, okay, work equals force times distance, is easily proven to be nonsense. That all that matters is time. How long do you apply a force? That's what decides how much energy. So if I push on a scale and I have to keep pushing it to hold it in a position, it's about how long. The work is about how long I'm pushing. It's about how long I'm holding a weight against gravity. It's about how much work I'm actually doing. And I just say that one's an easy target for you guys, okay, is that your crazy physics says I could be holding a 50-pound barbell, and I could be sweating bullets, and you're going to say I'm not doing any work because the barbell isn't going anywhere. And then if I start to jitter and I start to wobble, well, then you'll count the wobble as work, but you really won't count the bulk of the work as work, which on its face, come on. Does it make any sense for an MIT physicist to be holding up his briefcase and then saying, I'm not doing any work? Come on. All right. Well, anyway, you seem to have some confusion between momentum, yes, MV. Descartes, Galileo, and Newton all got right answers by understanding the quantity of motion is just about mass and velocity, and you don't need to know anything else. And Newton pretty much explicitly said that you can pretty much exchange a force for momentum. Momentum and a force are the same thing. You want to go twice as fast, apply twice the force. That's exactly what Newton said. So he didn't say anything about this A thing, this special acceleration that does all this special per second thing. So again, I mean, wasn't that in the video? I mean, the bulk of my video did have the per second thing, which is, again, where's the logic in this? It's a rate, 9.8 meters per second. It's a rate. You don't square the rate. You wait and see how many times you apply the rate. The rate is per second or per half a second or per millisecond. It's in units of time. And there's a number per any unit of time. So I could do 1/1,000,000th of a second and make it 0.00009.8. And I'm just going to apply it for those little units of time. And I just count how many units of time I applied the force. I put something 4 times higher in gravity. It only takes twice as long to fall. And therefore, it only has twice the energy, not 4 times the energy. It's only going twice the speed. It only weighs twice as much, and it only took twice as long. These, in my opinion, are completely undeniable, rational arguments pointing out why it's not about distance. It's about time. All right. And conservation of energy with kinetic energy. Right. I'm saying kinetic energy is a fallacy. It's a nonsense. It's a complete contradiction. You don't get the same answer. Anytime I convert energy between a light thing going fast and I conserve the momentum and I exchange the energy, so I use a lever or some device to make the conversion, every time I do it, I go one way, I lose a tremendous amount of kinetic energy. I go the other way, I make free energy. You can't make free energy. I shouldn't have to say that to a physicist, but you can't make free energy. So it's complete nonsense. There is no mv squared. It's a fallacy. It's garbage. It was bad when Leibniz suggested it. It was even worse when de Châtelet popularized it. It's unevidenced nonsense. It does not take 4 times the fuel to go twice as fast. You can't show a single experiment where that happens. And if you could show the experiment, well, then you'd have an argument. I would say, oh, wow, there is magical energy in the world. I mean, you still have a problem with all kinds of free energy, but I'm just saying, show me. And you can't show me. In 350 years, they haven't showed anybody it taking 4 times the energy to go twice as fast. Because it only takes twice the energy to go twice as fast. And I want to launch something in the air, I give it twice the velocity, it goes 4 times higher, and it does not land with 4 times the weight. It only lands with twice the weight. So again, this isn't my misunderstanding. The accusation is that your physics is babble. A big part of it, a gigantic core base foundational understanding of physicists is poo-poo. It's you're cherishing bathwater and you threw out the momentum baby. And also many other types of energy. So there's no types of energy. Energy is basically just mass moving in the universe. Anytime there's a mass moving, it is what we would describe as energy. And energy just means that whatever it is, relativity-wise, it has a different condition than something else, okay, that I can compare it to. So I compare it to something else, it has a different condition in terms of its velocity, its relative movement in the universe. And that's all there is. And you seem to think that these can't simultaneously be satisfied. I'm certain they can't be. There's no evidence they can be. Again, I can prove levers are free energy devices by your theory. And I can prove that NASA doesn't use it to land lunar modules because it doesn't work. I can prove lots of things to demonstrate that this doesn't work. If you use it to try to land on the moon, you won't land on the moon. You have to understand its mass and velocity that creates thrust. It isn't the 2,000 joules of the bullet and the 2 joules of the recoil of the gun. Violating Newton's law, it's not an equal and opposite reaction, but the fact is the spaceship will prove to you, okay, that the bullet has the same energy as the recoil of the gun. Okay, one doesn't have 1,000 times more energy. This isn't the case. Well, I'm saying says you politely, okay, but that's your challenge. Your challenge isn't just to tell me what the case is. Your challenge is to show me it's the case. Prove it. Show me a piece of evidence. Physical, real evidence that your theoretical statement has something to do with actual physical reality. All right, for example, let's say you have 2 masses connected by a compressed spring at rest. Yeah, and let's say you compress the spring with a known quantity. So you compress the spring with a 10-ton train going 5 miles an hour. So that's what you compressed it with, a 10 mass going 5 velocity. All right, the total momentum is 0. Well, says you again, it's like we already know it's there. We know the potential energy has been stored in the spring. We know what stored the energy. I put something on a scale. It has a weight. It compresses the spring. I can quantify the amount of energy. I can push it in this way, or I can push it in through gravity this way. It doesn't matter how I put the energy in. We know it's in there. So I first off would say, oh, whatever. You want to play the zero game, go ahead and play it. The idea is I put a certain amount of energy into the spring, and I know I can get a certain amount of energy back out of it. That's basically a storage device like a battery. I can put the electricity in, I can get most of the electricity back out again. All right, we know M1 times V1 plus M2 plus V2 equals 0. So again, I'm just saying this is already a mathematical gimmick, because what I know is that I put a 10-ton train going 5 miles an hour in. That's what I stored the energy as. The weight of that object compressed the spring. All right. The momenta of the 2 objects still add to 0. So again, just a gameplay, because I already know what the spring has. I know what I put in the battery in terms of the electricity. So I can pretend there's no electricity in the system, but that would be pretending, frankly. Okay, and it would be very difficult pretending for me to do, because that's like saying 2 plus 2 doesn't equal 4. I know what's in the spring. Momentum is conserved. So again, yes, we agree that momentum has to be conserved apparently, but what we don't agree is that you have to conserve kinetic energy. And so my argument simply is isn't it fake energy if you don't have to conserve it? Yes, I'd say it's fake. But there are a lot of values for V1 and V2 that could satisfy the equation. There's a lot of values that will destroy reason and logic. And so that's what the outcomes are going to be, and I'll draw that little part. So which is the one that would happen in reality? So I guess he's posing a question as if, but there are a lot of values for V1 and V2 that could satisfy the equation. Right, you're just saying anything. You're just saying that anytime I do the experiment, I have to conserve momentum. I'm already agreeing you have to conserve the MV. What I'm saying is if you put a square on the V, you're not going to do any conservating anymore, because every single time I'm dealing with a light object going fast that has the same momentum as a heavy object going slow, I will have unequal kinetic energies in the system. So if I create an oscillating balance with a 2 mass 1 unit of distance from the fulcrum and a 1 mass 2 units of different distance from the fulcrum, and it oscillates perfectly, it'll be oscillating with twice as much kinetic energy on one side that oscillates on the other side, which makes no sense. Okay. For that, you need conservation of energy. So, no point in saying conservation of energy when you have this ambiguity, this ambiguity about what you're defining as energy. So we use kinetic energy to describe something that opposed to potential energy, and that's one context you use the word in, and then use the other context in this explicit statement that I must square the velocity. Somehow the velocity is, potentially infinitely more powerful than the mass. It matters more. So unlike Galileo, Descartes, and Newton, I'm supposed to believe that the velocity is somehow twice, not more than twice, it's squared. So it's exponentially more important than the mass. And I'm saying to you, that's not a good understanding of energy. Starting with the energy stored in the compressed spring. Yes, so we know it's stored. I just pointed out there's some kind of pressure stored in the spring. It's not variable. It's momentum that pushes springs. It's pressure. It's weight. Weight compresses a spring, and we know by Hooke's law that twice the compression, twice the amount of energy, blah, 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 blah. Being that the spring constant and x being the compression of the spring. So again, we don't really have to bother with any of that stuff. We don't bother with battery constants. We know the battery can produce the electricity in any form of voltage. We can get a lot of voltage out of the battery and a low amperage, or we can get a high amperage and a low. We can convert it any way we want it. So let's not pretend that this constant even makes any difference. Okay, the thing that's all that matters is we know what we put in, and we're going to get 80 or 90% of what we put in out. And that is turned into the combined kinetic energies of the two launched masses, says you. I'm saying that's just nonsense, because it won't happen. You're not going to come up with the same number of joules. So even though it was a certain number of joules that compressed the spring, I just changed the weights you put on that spring, and I changed how much total energy I got out of the spring. So the input won't match the output. All right, so this is where I will draw. And see if you'll participate in responding to some of these points, in a reasonable manner. I mean, reasonable is you have to produce some evidence somewhere. You can't just keep saying it's the truth. You have to show it to be the truth. And okay, there's very few people demanding to see the truth, but that's the challenge. All right. So here's the example he's provided. All right, simple kind of thing. I take a spring. Okay, let's draw it way up here. Okay, this is its relaxed position, and now I put the energy in. So I hit it with the 10-ton train going 5 miles an hour, and I compress it to this amount, and I have a little lock on it so I can prevent it from expanding. So it's now a little locked battery. And the simple argument to you is I know there's a certain amount of energy in here, so let's just call it 100. So it has 100 joules of compression. Okay, that's what I put in. Okay, I put in a real amount. I put in a 10 mass going 5 velocity. So I put in a real amount of energy. That's what's stored in the spring. Now, if I just sit here and I do this simple thing and I put a 1 mass here, okay, and I put a 1 mass here and I expand the spring, okay, I'm not going to get this momentum back, okay, because now I've changed the mass to velocity ratios, and with the 1/2 mv, with the mv, the living force theory, you know, the Leibnizian wrong religious, you know, silly theory, I'm going to get, say, I could just make up any number, I'm going to get 300 joules. Because of these fast velocities. These are going to leave with not 5 velocity, these are going to leave with 20 velocity. Right? 20 velocity over here. Very high. You know, and then I put the 2 objects here again, and I do it with, let's say, 3 masses, okay? I'm still going to end up with more, okay? So I'm going to keep ending up with more energy. So if I go to the 5, for example, which is my favorite, all right, to complement this, you could just say this is the same as a 5 mass going 10 miles an hour. All right. So when I finally get to the 5 mass going 10 miles an hour, I mean 5 mass, okay, and the 5 mass, what I'm going to get, and by conserving the momentum, when I conserve the momentum that went in, and now I'm going to put it to bring it out. Now I have 2 objects. So now they're going to leave with each having 10. Okay, so now I've put both of those into the universe. Now obviously I could just change the experiment and put this as a brick wall, and then I'll know I get all the energy back in one direction. And if I get it back in one direction, I'm going to get 20 here. Okay, I'm going to get a 5 going 20. This is going to be unyielding. So I'm going to get a more perfect reflection. The reflection gets less and less perfect the more yielding the other side is. The less yielding it is, the less perfect it is. So this will leave with 20 instead of 10. You'll say it has twice the joules, and it doesn't. It's this amount of energy that went in, okay, the 10 and 5. And so, again, if I brick walled it and I have the 10 mass on there, I have the expectation I'll just get back the 5 velocity. All right, and that's when I'll conserve momentum and kinetic energy, is when I have exactly the same mass. But in every other case, where I make the mass heavier, I'm going to start losing tons of energy. And where I make the mass lighter, I'm going to be making free energy. I'm going to have more joules out than I put in. And the same is true for just something as simple as a lever. I can make a lever and put the 2 mass here and put the 1 mass out here. And the simple argument is I could say this was a 10-ton train going 5 miles an hour, a 10 mass going 5. This is a 5 mass leaving with 10 velocity. And your argument is I won't conserve this momentum. If I put the 10 mass here, 1 unit of distance, and I just set the 5 mass over here, I'm not going to get conservation of momentum. Because if I do, I made free energy, right? Because I'm going to put 100 joules in over here, and I'm going to get 200 joules out over here. Because this is going faster. The faster velocity means I square it. It means I end up with free energy. And if I do the opposite, I put the 5-ton train in, I let the 5 mass hit here, you're going to argue that I lost 1/2 of all the energy. So all the energy, 1/2 of all the energy I put in, I'm going to lose, because this is going to fail catastrophically to, it's going to lose velocity. So it's going to be a 5, it's going to be a 10 mass, only going 5. And therefore it's going to lose a huge amount of joules of energy. It's not logical. It doesn't work. It fails the lever test. You'll never show, again, it taking 4 times the energy to go twice the velocity. Okay, you'll never show that to be true. 4x energy equals twice the velocity. You never show that to be true, ever. And obviously it gets worse and worse. The faster I make this number, 4 times the velocity, this number goes to 16 or whatever. It just gets worse and worse and worse and worse. It's obviously doesn't calculate. It's not mathematically sound. It's not consistent. The theories are in complete contradiction to each other. You can't believe in momentum, the conservation of momentum, and then believe in something called kinetic energy. The two ideas are fundamentally in conflict. The conflict was known at the origin of this theory. It was resoundingly defeated by the Newtonians, and then it was dug up as a cult idea, 50 years later. Okay. This, along with conservation of momentum, allows us to specifically calculate how the two masses will be launched by a spring. I'm saying your calculations have nothing to do with reality. You claim an outcome, you don't show an outcome. You'll never show it taking 4 times the fuel to go twice as fast, because it's nonsense. I can compress a spring to twice the compression by doing 2 times the work, by just putting 2 objects on a scale. Twice the work creates twice the compression. No problem. So it's unviable. It doesn't work. It's completely inconsistent. Doesn't have anything to do with reality. And your real obligation is, if you're going to say somebody has to believe this to be a good scientist, then you really should be able to produce some evidence. All right, both momentum and energy, like showing how NASA uses it to navigate a spaceship. Again, do you think if a NASA spaceship was flying through empty space and it shoots a bullet out one side, at one moment, and it retains the recoiling gun's energy, so the recoiling gun is now going to hit the side, and in the other case it lets the recoiling gun flies out and it keeps the bullet in the spaceship, do you think the bullet with the 2,000 joules means the spaceship is going to radically turn? Or do you think, as NASA believes, NASA knows, the bullet is the same as the recoiling gun? It's the same amount of energy. 1,000 atoms going 1 mile an hour, same thing as 1 atom going 1,000 miles an hour. It's the same quantity of motion. It's the same thing that Newton got right answers with. That works. Your theory doesn't. All right, but momentum and energy are exceedingly useful ways of describing. So you say it's exceedingly useful. I say it's only useful if you want to build a unicorn. So if you're out to build a unicorn out of physics, then it's useful. But if you want to get the truth and you want to see reality for what it is, it's completely unuseful. It's massively destructive to any rational grounding of physics. And that's why physics is full of crap, frankly. All of the extra fancy phantom particles they've invented, like neutrinos and the rest of it, are all invented out of mathematical extra energy left over from the kinetic energy formula. It's the free energy problem. They end up, every time you break something from bigger things into littler things and you conserve the momentum, you end up creating the illusion of more kinetic energy, and they have to create fake particles to carry that. And so it's exceedingly destructive to rational understanding of physical reality. That's the truth. It's exceedingly destructive. All right, useful ways of describing and predicting the motion. So again, you don't predict the truth. Your predictions are actually rubbish, silly. You predict the spaceship turns. I shoot the bullet out one side, boom, I turn radically, compared to the gun going out the other side. So the two don't balance each other, and the net force is 1,000 joules on one side and 1 joule on the other. And so I turn the ship radically when that won't happen. Predicting motion of physical systems. So again, you don't predict reality, you predict a fantasy. You're predicting your hologram. So yeah, you make up a fake world to create with a fake piece of jargon and math. Okay, I'll probably put together a much more detailed series of conservation of energy later. Well, combine the two things. Show how you can conserve momentum and conserve kinetic energy. And you can't. So one of them has to be a right answer and one of them has to be a wrong answer. There are two ways of understanding motion in the universe. there's just no point, in my opinion, of telling me they both get the right answer. They don't get the right answer. They both get very different answers. Momentum says there's the same amount of energy in one case, and kinetic energy says there's different amounts. I mean, you can't say these things are compatible theories. They're not. Okay, as you point out, I'm just getting back into producing YouTube content, and that's good. I'm glad, and like I said, if I can encourage you to stay on these fundamental elemental subjects, which in my opinion physics has gotten all wrong, wave-particle duality, for example, way off the reality. But I'd recommend, whatever. I mean, I can recommend you probably should eat more vegetables, frankly. So if we're going to give each other recommendations, I'd recommend you eat more vegetables. I'd recommend looking up Nether's theorem. Why? It's bad math on top of bad math. It's like telling me to look up the work equation. Why would I do that? It's a piece of rubbish. It's a piece of garbage. Who says it has anything to do about distance? What is distance? Yes, you measure velocities by taking a tiny amount of distance and measuring it over a tiny bit of time. But yeah, the time part's the important thing. 9.8 meters per second. Gravity is a time-dependent force. It's not it doesn't have anything to do with distance. It doesn't care. So again, I've done this so many times. I mean, you're an astronomer type physicist. I have a gravitational body. I have a certain amount of exposure to gravity. You could just say realistic gravity, right? Any of the gravity too far away ain't gonna matter. It can't add up to anything. I could have an infinite amount of that distance and it wouldn't matter. Well, anyway, so I have about a distance, a mile. And I'm going to travel through that mile next to the gravitational body. What's going to matter? The distance, the mile, or how fast I go through the gravity, right? The faster I go through the gravity, the less I'm going to get affected, the less it's going to push on me, the less the gravity is going to affect me. So I'm going to get a tiny bending if I'm going fast enough. If I go really slow, like holding the weight, there's no work not being done. Gravity is working on me every one of those seconds, every one of those milliseconds. Gravity is working on me, and I'll crash into the body. But if I go fast enough, I'll go right through it. Obviously, the work gravity will do will be completely time dependent. If I have a fast enough velocity, gravity does no work. If I'm going slow enough, it does a ton of work. Come on. I shouldn't have to make these arguments for 10 years. Anyway, where was I? Well, we'll just start over. I'll probably put together a much more detailed conservation of energy later. As you point out, I'm just getting back into producing YouTube videos. But I'd recommend looking up Nether's theorem. So, yeah, this is just the convoluted math. So, Nether's theorem just has to do with reverse engineering any conservation law. And frankly, there's no definition of conservation of energy, because you're playing a game saying in one case energy is momentum, in another case it's kinetic energy, and you can't conserve both at the same time unless you have exactly the same masses going in as you have coming out. As soon as I change the masses and I conserve the momentum, I'm going to end up with different amounts of energy. So there's no way there's no point in checking the conservation law when obviously your check for the conservation law has got to be pretty broken if it hasn't already pointed out to you that momentum and kinetic energy are not compatible theories. For a deeper physical framework of how you get different conservation laws. So there's only one conservation law. I mean, this is like a word game, okay? There's no conservation of heat versus conservation of momentum versus conservation of anything. Energy is all the same thing. It's just mass moving. You have to conserve the mass and the velocity. And they are, in fact, equal players, and that's the conservation. That it really doesn't matter because they're both providing half the equation. So it doesn't matter how you mix up the numbers, switching from one side to the other, because it doesn't matter whether it's 2 times 3 or 3 times 2. It's the same answer. Like conservation of momentum, conservation of energy. So this is all kind of conservation of force, conservation of it's all the same stuff. So force, energy equals force. Newton says so. Okay, it equals weight. Okay, it equals pressure, it equals heat. All of this stuff is the same stuff. It's just mass moving, and the masses just get smaller and smaller. So yeah, we can't see heat as readily as we can see a 60-mile-an-hour car go down the road, but we can know of its essence is made out of mass moving. All right. Conservation of energy, conservation of angular momentum. Well, angular momentum doesn't mean anything either. I mean, the angular momentum is just made out of the velocity of individual pieces. So I could just break the battery into pieces, and I just say, well, what's the total amount of velocity the pieces have? And so if I compress the pieces here, and they're moving very slowly, okay, or I can put the pieces way out here and they're moving very fast. Obviously, this going fast takes more energy than going slow for the same size piece of substance. So angular momentum is just the fact that you've tied the things and they're forced to change direction, but you can't change the fact that it's just masses moving. I just break the object into masses moving. I can have a lot of mass on the outside of a wheel, or I can put all the mass in the center of the wheel. And I just know that, though, yes, the one with the masses in the center has less energy. If it's the wheel's turning at the same speed, I'll know one has more stored energy because one has put more energy in to move the same amount of mass at much higher velocity. I could even revert that to time dilation and all the rubbish about bent space and just point out how all of that theory breaks down if you just understand that when you're rotating on the Earth, you're moving up and down in gravity. Gravity's pushing you into the Earth, the Earth's pushing you back up, you're jiggling. And so you're not moving this straight line path across the Earth, you're doing this across the Earth. So you're moving like the basketball, you're going a lot faster than the basketball player. And that is why heavy gravity means you're moving at a faster velocity, is because you're moving more than one direction. All right, so where was I? Yeah. From physical symmetries, okay, spectral translation symmetry for momentum, time translation symmetry for energy. So again, yes, energy is just about time, and there really isn't, I don't know what the spectral thing would be, rotational symmetry for angular momentum. These are all just jargony words. It's all the same thing, and the symmetry means there has to be conservation. So there's the same amount on one side of the circle as the other side of the circle, and those are the assumptions. And so obviously, again, when I put electricity wattage into a battery, I put a certain amount of wattage. I can't make more wattage out of it, okay, and I don't lose it gratuitously. If it loses energy, it loses it in a specific way. It gets hot, it does something. It doesn't just magically lose. Look, your physics says I have a 10-ton train, a 5-ton train going 10 miles an hour. I double it by dropping another one on top of it. Now I'll admit, okay, because that's how the experiment comes out. So I start off with a 5-ton train going 10, right? I just, in a very simple way, double the mass, and now the experiment produces the result, which is almost all the momentum is conserved. Just a tiny, tiny, tiny loss, 1% or less of the momentum is lost. And yet you'll say this has half the energy, and somehow it lost half the energy in all kinds of bizarre ways. It made sounds, it bent metal, it heated things, it made sparks, it did all kinds of crazy shit that we didn't see any of that, right? There's no measure of it. No one shows us that happening. So this is a real experiment. This experiment is done, okay, with little carts. So you have a 5 velocity and a 5 mass and a 5 velocity. So 10 mass, 5 velocity. No. 5 mass and 10 velocity. There, I add a 5 mass, and now I have something that physically is just a 10 mass going a 5 velocity. That's the physical reality. And your argument is that even though I have the same exact momentum, almost 99% of the momentum has been conserved, you're saying, okay, I did a bunch of work. I did a bunch of heat. I did a bunch of mechanical stuff happened that used up half the energy of the system. Half the energy of the system is now in some other form, and yet I have all the momentum. So even though I still have all the momentum, I lost a bunch of energy. You can't see how that paradoxical piece of rubbish as an idea can't possibly be the truth, that your theory can't possibly be true, that this has half the energy of this, and this, that these two things are in fact equal things. A 5-ton train going 10 miles an hour is the same thing as a 10-ton train going 5 miles an hour. They will produce the same weight against a spring. If I smash them into a spring, they'll do the same thing to the spring. All right. I find it to be one of the most interesting physical concepts. Okay, so that's a little weird to me, sorry. So obviously you love math and convoluted math, because I really don't see it as being very interesting, frankly. It's like the whole Bell inequity crap. It's pretty convoluted and, sorry, no sale. And it's extremely useful. Again, this useful word in terms of, yes, it's useful if you want to propagandize and talk about wooey fantasy physics. But if you want to get to the truth, I don't think it's useful at all. It's completely destructive to humankind getting the right answer and not being completely mocked by the aliens eventually. Now, I don't believe in aliens, but I'm just saying, if there were aliens, they would laugh their asses off that we fell for this 1/2 mv squared crap. In concepts from quantum field theories, and again, which really don't produce consistent or reasonable answers to simple questions, to general relativity, which is just a big pile of made-up nonsense. Okay, there is, in fact, relativity, Galilean relativity, but there really isn't any kind of notion that there's not an absolute three-dimensional universe, and you have to obey the rules in the 3 dimensions. It takes speed to travel time. It takes speed to travel distance, and that's just a fact. And the speed limit seems to be consistent with all the forces. They all have the same speed. Gravity, magnetism, electricity, they all have the same maximum speeds. It's worth a look if you're interested in the topic. So, yeah, no, I'm interested in the topic of the elemental contradiction stated, okay? Science says a bunch of things that they've proven beyond reasonable doubt. They've proven beyond nail in the coffin evidence, as they'll say. So they've nailed in the coffin something like wave theory or some other crap, and my point is it's not even close. They don't even have corroborating evidence. They never repeated the Eddington experiment from space. They never proved light is twice as bent by gravity. I mean, none of it is proven physics. None of it is substantial and hard and reliable and definitive. It's all just a bunch of vague, mushy, circular physics. So they created a fake work equation to basically make it a circle. So they took mv squared and they could make a circle through the fake work equation and make it coherent in terms of internally consistent, and they just didn't care that it doesn't get any right answers. Young's double slit drawing is a pile of crap. It doesn't get the right answer. Okay, its dimensions are all wrong. It won't predict as you claim. Physics keeps claiming it has the most predictive theory in the history of mankind. These are not accurate predictions, frankly. If you used the 2-wave analysis on the double slit, you will not get a double slit pattern. You'll get a single slit pattern. It doesn't work. And you just keep all preaching this garbage and then kind of arrogantly dismissing anybody who says, wait a minute, that doesn't work, by saying they misunderstand. And I understand people doing that. I'm just saying not to acknowledge you don't have the evidence. The fact is, you can't show me it taking 4 times the fuel to go twice as fast until you can show me that being true. Until you can show me it taking 4 times the gasoline to get a car up to 60 miles an hour from 30 to compared to 30, or any other system that requires this huge, insane amount of extra energy used to go extra speed. So every time I go, if I go 3 times as fast, I need 9 times the fuel. If I go 4 times as fast, I need 16 times the fuel. I mean, it's a preposterously inaccurate statement. It doesn't work that way. Things get more and more efficient the faster you go. The faster you launch something from the surface of the earth, the less you pay per foot for the distance you acquire. So if you want to get I don't know, 5 miles up, go really, really fast, and you'll get there sooner, and you'll fight less gravity. And that's the simple truth, because all you're really fighting is time. Gravity is a time-dependent force. The faster you get through it, the less of it can touch you, because it touches you the same way per unit of time. It's just about time. And you want the gravity to take less from you, then all you got to do is reduce the time it's taking, or giving, in the case of giving. So, man, I think that's a pretty good argument. Let's see what else I could throw in. But yes, the conversation needs to be based on experimental evidence. So you have to show the experiments that you think are convincing in terms of providing a substantial proof that there's any such thing as this concept. And I'll just keep drawing levers and pressurized vessels and different other mechanisms that basically, in my opinion, show it can't possibly be the truth. What you put in is going to produce a certain result. So maybe I'll just draw the hydraulic example and to just demonstrate. I mean, really, do you think an 8-pound bowling ball going twice as fast as a 16-pound bowling ball, do you really think it can knock down twice as many pins? That it's going to give the total energy to the pins is going to be twice as high? Really? Twice as much motion in the universe will be created by the 8-pound ball going twice the speed. So like the lever, as a simple definition of the problem. So the lever theoretically can do the bullet, right? I can have 1,000 units of distance over here and 1,000 times less 1/1000th of the mass. All right, and I can have this over here. Okay, the gun. And the truth is it conserves the momentum. So the idea would be is that, yes, I can make that oscillator. I could put the recoiling gun energy on one side, and I could put the bullet's energy on the other side, and it will continue to oscillate because there will always be this relationship of distance here. Distance from the fulcrum just equals velocity. And as I go further and out, I go further out, I go further out, I just keep increasing the velocity, and that's all it's really about. All right, so the other circumstance you can sort of, prove the case with is if I can just make a hydraulic system. No, I shouldn't have made this so big, because it just ruins the visual of it. Okay, so these cylinders are all the same size, so I just tie these two cylinders to each other. So this essentially becomes my, the 10-ton, mass, and this is the 5. So anything I push here, okay, over twice the surface area, I'm going to get twice the velocity here because I'm pushing a volume. So it's just going to be about the volume going in and out. So if I put the energy in this side, okay, I'm guaranteed to lose a ton of energy because this is going to move 1/2 the velocity. All right, that this will move. And then vice versa. And whatever velocity I push in here, I'm going to guarantee to get 2x the velocity coming out over here. And, doesn't that just prove that there's no way this kinetic energy thing can make any sense? I can't produce, I'll push in on here and somehow I make free energy coming out the other side. It just doesn't make any sense. So whatever mass I put here, I can have anything sitting on here, a mass, a pressure, and I put a pressure in here. And the pressure I get out here is going to be the same pressure. It's not going to be a different amount of pressure. It's going to be the same amount of pressure. It's just going to happen in different units. So it's going to happen in, this whole idea of just understanding it as a big M and a little v versus a big V and a little m. And that's all you can do is these conversions. But the total weight of mass and velocity, that is the total amount of it. And weight is the real thing, but that's what this is really equals. It's just weight. Okay, this equals weight. The weight here will be the same as the weight here. All right, you can't say one of them has more energy because it moves a little bit faster and it's lighter. I mean, it's not. It's the same stuff. And this is what you have to conserve, is this weight. There has to be a conservation of pressure, conservation of weight. And you'll end up with this, like I said, a free energy theory. I just go outside and I jump on a lever and I produce free energy all day long. And I make a machine out of the fact that every time I push on a lever with a heavy thing and launch a light thing, I'm making free energy. Okay. So let's see if anybody's here. Maybe I'll leave it at that, because to me it's a pretty concise, to the point, bang, argument should be over. Okay, I wish you would do live streams on your... Well, okay, whiny, complain. It's just whatever. Why? Why would I do them? Exactly. So I can just listen to trolls all day. But whatever, we'll see. It may happen. We all wish there was free energy. I don't know, we all do. Yeah, I don't know. It's just kind of a funny... I mean, it's, energy is pretty cheap. And just imagine the mess people would be making to the earth if energy was free. The waste energy. And so we'd really have a greenhouse problem. Because it's really the heat on the surface of the earth. It really doesn't matter whether... You could argue that both human activities, the releasing of the carbon is bad, but we're also heating the surface of the earth with all of our industry and all of the gases that come out, or the smokestacks are hot. We're doing a lot of thermal work, okay? And that's the real trick, because the warmer the air is, the more water it holds. And it's water water's like 100 times more of a greenhouse gas, water vapor, than carbon dioxide. So, it might not just be the carbon dioxide that's the problem. It just might be the symptom of releasing the carbon dioxide releases heat. And we've released a bunch of waste heat. And that waste heat is going to make, things hotter, because it's going to make things humider. It's going to make things hotter, and that will make things more humid. And if you make things more humid, you're going to make things hotter. Interesting. I don't know why you're deleting your own comments, but go ahead. It's your prerogative. So it's great that this guy isn't super popular again yet. I mean super popular. He was never super popular, but I just mean things are, he's trying to get back in the game, and so he actually read my comment, and he actually felt provoked to respond. So, this is a very unusual case where we get the physicist to respond to a comment. Now, it has happened in a few cases before, but the first response is, you just don't understand, and then they just throw a bunch of theory, and you can ask all day long for, show me the experiment. So just show me the experiment where, I could show you a Mythbusters experiment where they kind of prove there's no kinetic energy by accident, but, I mean, you don't have an experiment. Show me you collecting the kinetic energy. Hydrolysis? Yeah, think hydrolysis. Why do I need to think anything? I mean, realistically, why do I need to? Obviously, if you throw electricity into, breaking hydrogen and oxygen apart, that again creates heat. So, I guess you're saying hydro in terms of water or something, but whatever. Yes, obviously it's, I use simple words. I don't know. Hydraulic, yeah, whatever that is. I don't need to worry about that. It's just moisture in the atmosphere. In the upper atmosphere. Well, whatever it is in the upper atmosphere. I didn't think there was all that much in the upper atmosphere, except, few atoms here and there and all that kind of crap. you kind of need a density of atoms to do any real greenhouse work, right? I mean, tiny, thin, undense layers of the atmosphere, in my opinion, can't do much work in terms of creating energy traps, you know. So I think you do need the heavy atmosphere to block the reflected sun's energy. And again, it all has to be reflected when you think about it, because yes, if it's not reflected, then the surface of the Earth would melt, you know. So we're a long way from that, you know, we're a long way from Venus, but I'm just saying that's the whole point, though, is that how did Venus get where it got? It got there by breaking a threshold, where it got to a point where it created a greenhouse system that was self-sustaining, that the more hot it got, the more hot it could get. And that's sort of the phase we're in the sense that we can put a lot of moisture in the atmosphere. So you could argue that the giant flying insects and stuff only worked in the prehistoric eras was because the air was so thick. They were actually swimming, you know, in the air. Because the air was that thick. It had that much moisture in it. It was so humid that, you know, and that's why all these plants thrived and all that kind of stuff, is because it was really, the heat was being dissipated through water, which made even more consistent a temperature increase. So you didn't have these hot spots, you know. You were more in just a nice bathtub of warm water. And that's why there were giant ponds, you know, like they had to drain. I mean, the Grand Canyon is just sort of an evidence of what happens when you start to make the planet less humid, and you don't have the same water available for rain, for redistribution onto the surfaces, the continents. So you're distributing a lot less water onto the continents because the atmosphere holds a lot less. So, you know, all of that stuff is sort of interesting physics, and you could spend, a great deal of time analyzing all the little different variables that go into the equation, because it is interesting. I mean, the methane is a worse greenhouse gas also. It doesn't last as long as the carbon dioxide, but it's worse. And obviously every time you make things a little warmer, you know, especially in the Arctic, you release a bunch of methane. And so again, it's not the carbon dioxide directly, it's the indirect consequence that that little bit of carbon dioxide adds a little bit of temperature increase, which adds a lot of release potential for a bunch of stored crap. But I really think the simplicity of the argument, you know, I just keep making the simple argument. Clearly over the epochs of time, okay, that living things have been on Earth, what they have done is stored a bunch of carbon, okay, in the ground. So a bunch of their unfully decomposed bodies, their batteries that didn't get consumed, and so they still have the energy in them. Those batteries kept being buried, and the burial of all of that energy meant that the atmosphere got cooler and cooler. And so slowly but surely they took carbon out of the atmosphere and put it in the ground. And then obviously, very rapidly, we've taken a ton of that black crap and, you know, that stuff full of that, you know, heat, and we put it back in the atmosphere, you know. So it's kind of obvious, in my opinion, just count how much where the black crap went. And you know, we've obviously put it back to some previous millions of years ago. We're in, you know, in a few hundred years, we're going to do what it took nature millions of years to do. Kind of weird there, I got to tell you, this whole retracting your comment thing. maybe somebody who is not going to retract everything they say will say something, huh? Yes, let's see if that happens. So, I guess we'll give a 2-minute warning and such. See if anybody has anything to say on the subject. Kind of an important subject, frankly. The fact that physics might have made a pathetically not very bright mistake 350 years ago and accepted a notion of reality that's just phantasmagorical mush, and there's really no reason to believe that mass and velocity aren't equal players in the energy game. The mass is the carrier. That's simple. The carrier is just as important as the thing it's carrying. You got to have the bucket to collect the water. The rain. And it's just how long is your bucket facing the rain that decides how much rain falls in it. I mean, that's such a simple, obvious, to me, obvious metaphor for forces like gravity. That they're just rain. And you're just saying, how long am I in the rain? That'll decide how wet I get, how much energy I collect. And as soon as I hit another surface, the bucket empties. I go back to having an empty bucket. What do you think of Earth expanding due to water? I think it's absolute silly nonsense. The expanding Earth doesn't work because you can't do it with the whole Moon-Earth relationship. That's a really proven old relationship. The cycle of the Moon, the orbit of the Moon, all of that is millions of years old. Can't die. Why are you doing this retracting thing? I got to ask the question. Why are you doing it? If you don't want to answer the question, that's fine, but it's really annoying, frankly. So quit doing it. If you're going to retract your messages, go somewhere else. Why don't people have such weird personality tics? It seems everybody you meet, they seem all perfectly normal, and it's like some kind of Simpsons episode, where he changes time, and then they have a lizard tongue, or they have some kind of weirdness. And it's like people have all kinds of these effects. They're all affected in some kind of way, and it's always annoying. It's like they're perfectly normal. They walk up to you, have a conversation, they pick their nose and throw the booger in your face. I mean, they have some kind of silly tick or twitch or something. I guess I am the same way to people. I mean, I probably have some personality defects or mannerisms that people could find annoying. But damn. I couldn't even read that one. I always remove comments for some stupid reason. Well, I'm going to block you then, okay? So just quit commenting. You got it? So if you do it again, I'm just going to block you because it's really stupid, fucker. It's just absolute nonsense to post a comment and then retract it 14 seconds later. Whatever you're doing, whatever the plan is, I don't like it. I don't want to be part of it. Go do it in Russia or something. I hate agendas. But this is how the internet works, right? I mean, the low wattage internet works like this. I mean, it's all these defective people show up, and they do all this defective crap. Just oh, God. It's just so damn tedious. It's hard enough. I mean, the language barrier, we're sort of getting over that, which is really quite good. That people can do the translating thing. They can, sort of participate, blah, blah, blah. It works a little bit. But all this other crap, this don't work at all. So, 2-minute warning, I guess. Nobody else is about. Only 11 viewers, blah, blah, blah. So it'd be really nice. I will pay if the other guy's still listening. Okay, physics, whatever he was called. Sorry, I should remember your name by now. This guy, physics, Michael. So look, Michael. I've been doing this a long time. The 10 years you haven't been on the internet, I have been on the internet making all these damn arguments about how physics is full of crap. And I would absolutely love for you to debunk me, okay? And either in person or in video responses. And I really don't, if I have to pay you, I'll pay you, okay? I'm not going to pay you the $3,000 I've offered other people because, obviously your channel doesn't get enough views for that yet. But damn, these are really important subjects, and physics has just whitewashed right over them. The whole, again, I can go on and on about the two-slit experiment. I could point out that I have a channel called debatephysics.com. Okay, I guess that's over here, yeah. And, I do have some of the better videos on the subject, I would argue, listed. So we have the kinetic energy subject here with a group of videos, and the last one is always the best one, I would argue. And so I just went through the actual physical arguments explaining why this kinetic energy theory is garbage. And then I have the two-slit experiment. In all these videos I do explain why this thing, the propaganda is insane in sense of the mischaracterization of the pattern that's actually produced, and the mischaracterization of what could be possible cause, because it can be demonstrated by radar experiments, for example. Radar experiments kind of prove that it has nothing to do with waves interfering, because I can make the interference pattern by putting the other antenna, the other source, on the opposite side, and I'll still get the same interference pattern. How could these two waves interfere with each other coming from opposite directions? Not very likely. And entanglement and relativity and the Eddington-Bent light fallacy. This one's related to the kinetic energy thing, in a sense that it's the fact that it shouldn't be MGH. You shouldn't be measuring distance. You should be measuring time. You want to know how much gravity is going to affect you? Just measure how much time you're freely exposed to it. And then Veritasium silly electricity video. Bunch of videos on that. And there was the wind one too. I probably should do that one because I was the only one who got the right answer on that subject. So anyway. But whatever. There's lots to be debated, and it seems quite apparent that physicists won't debate any of their axioms, their premises. The things they say are undeniably true, and we're certain it's true, and we know it's true, and all that crap. And it is crap. I don't know if you could even see any of that. No, you couldn't. My bad. Okay, so I explained the channel, but I didn't do any better than that. So that was really poor performance on my part. So this is what I showed. That the debate physics just has some of the better videos on the different subjects. So if you want to do it the shortest cut way possible, the last arguments are usually the best arguments. Anyway, alright, well, we'll see if there's any other chatters and then get the hell out of here. Alright, maybe it has something to do with Einstein being also a patent looker over person. Well, the fact that, there's always a little bit of a cheaty thing going on, right? So I was talking about Leibniz. Leibniz, in my opinion, was like Tesla. And, all these people did have that in common, is that they did, Tesla read everybody else's papers. So Tesla was kind of a thief, frankly. A lot of it wasn't his own idea. It was other people's idea, and he figured out, where they could take it a step further. And Leibniz was a lot like that. He opined on all subjects possible, And he opined on them through understanding. Like, he was a meticulous paper. He kept every letter, everything written. I mean, he was, he's one of those, all these guys have to have some sort of idiot savant tick to be able to function at the high level they function at. But he was a compiler of data. He did travel all over the world. He did meet everybody. He did see everything. He did go to the library that had Newton's letters in it. I mean, all that crap happened. And, but anyway, to do with Einstein also being so, the fact that, Einstein was a patent clerk really gave him a familiarity with engineering. His father was an engineer, trying to build electrical systems or something. And so, Einstein had a real connection to that, and engineering solutions. Oh, you did it again. I told you not to do that. Didn't I tell you not to do that? All right, I'm just gonna sorry, but I can't put up with this shit. I'll put you in a timeout this time. Maybe you come back and you try again, but I'm just not gonna do it. Fuck you. I don't know. I asked you to tell me why you did it. You told me why you did it in one sentence, and it wasn't there long enough for me to even read it. I mean, what do you think? This isn't obnoxious? You're throwing boogers in my face. I don't like it. Stop doing it or fuck off. God damn. Jesus Christ. I mean, how stupid are you people? I mean, fuck, I tell you to stop. I don't like it. It's irritating. It's fucking me up. And you still goddamn do it? Jesus. God, there's just no hope. You cannot communicate with human beings. They are just such fucking assholes. Damn. I mean, if they're not lying scum, they're whatever, whack job Looney Tunes who have to delete all their comments. There, a little bit of nicotine and everything's all right again. Okay, 2-minute warning again. Fuck, get the hell out of here. This hopeless mission of communicating with the aliens. Damn. Really shouldn't be this hard. It's just not that. It really just shouldn't be this difficult to have a rational conversation with a human being. But saying it shouldn't be doesn't change that it is. It's only 10 little viewers now, so we're running out of fuel to make any fire out of. Alright, I guess you people just don't have anything. The ones viewing just don't have anything to say. Oh, it'd be really great if you get him to show up for a debate. Oh, it'd be really good if he makes a response video and actually has some kind of evidence in it. Oh, it'd be really great. You could say something. No, nothing. Absolutely nothing. Damn. Yeah, I could do another subject, but I won't bother. That's all. You don't deserve more of my time, frankly. Yeah. I do have plants to water and grass to cut and whatnot, so I'll go do that. Fuck. So, till the next time and such, I guess. That's all we got. Blah, 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 blah.